Guys, we are now on to our last little slide, our little slideshow. This should be a little bit quicker than the other two, but we're going to talk about how the science revolution expanded into medicine, anatomy, and chemistry. Again, I think I'm going to do a better job than I did first block because I was rushing. Hi, guys. So let's look here. All right. The number one thing you need to realize is where Aristotle needed to be disproven in the astronomy, Galen has to be disproven in medicine, anatomy, and chemistry. Okay. Galen was the holier than thou hero of the humanists. They believe they have rediscovered all of his truth. Well, on this side of history, we know most of his truth was wrong. Now, I don't blame Galen for that. He had a very limited technology and there's some other barriers. We're not going to talk about that. But what we're going to talk about is the astronomy, the scientific revolution through medicine, anatomy, and chemistry. Let's start with Paracelsus. Paracelsus may in fact be the father of modern medicine. Very unique. I do want to make sure you understand this is all about the birth of Western medicine. He rejected Galen's view on medicine. He developed this thing called microcosm, macrocosm view. Now, macrocosm is the larger. Let's just think about the Newtonian world machine, this ginormous machine that is governed by natural laws that can be discovered through reason and logic, right? Well, he said if that's true about the macro world, then the micro world is also a smaller version of these machines. And he viewed the human body as a natural body, a natural order controlled by natural laws, and that you need to utilize your reason to draw conclusions. So macrocosm is the larger Newtonian world machine. Microcosm would be us, the individual bodies. And the rules that govern the universe are the same rules that govern our internal. And we'll see that with Vesalius and Harvey. He developed the like cures like. This is really a change, right? It's the chemical principle of medicine. He wants to give you the illness to help you overcome it. Cure likes cure. Like cures like. I should fix that. I'll fix that later. But ultimately, what that means is if you catch a disease, if you get a little bit more of the disease, then it can help bring balance. Well, this is what our principles are today. You might even jump to the conclusion that this is very similar to the what? Vaccines. I do not know if it's a direct correlation, but I'm going to go ahead and deduce yes. So all of the modern medicine Paracelsus does is. Now, the funny thing is, despite its successes, he was widely rejected. What was he called? He was called the homicide physician by his peers, even though his cure rate was better than theirs. But why was he so rejected? I hope when you were doing your power map, you realized he was a jerk. He thought, well, by him calling himself better than Celsus, which is an ancient doctor, he would say, my poop don't stink. And does anybody want to hang out with people that are like that? Arrogant people? Not at all. And because of that, his impact will be not immediate, but long-term. But again, chemical principle of medicine, like cures like, microcosm, macrocosm, all of this becomes part of our medicine today. Now, let's look at anatomy, the father of modern anatomy. This is actually one of the pages in his book. You can see here, Vesalius. He's demonstrating how he has dissected the human body and he has somehow found the nerves. Kind of cool. This is the cover of that where you see the skin has been taken off. And then this is another page because what he did, he was the first guy to officially was able to dissect. Now, clearly he borrows heavily from Leonardo da Vinci, who illegally dissected human beings. But what we see here, Vesalius gets the full credit. He was actually trying to prove Galen, but through his observations, he was able to identify the major errors. One of the major errors was, guess what? Your liver is not the center of your circulatory system. Thank God. And in 1543, he published the same year as the revolutions by Copernicus. He publishes the birth of anatomy on the fabric of the human body. On the fabric of the human body, he's the first to identify the skin as the largest organ, and he was able to identify some of the things. Now, with that said, I want to point out Vesalius still held on to some of the wrong things by Galen, like we had two different blood systems. Not true, because again, he didn't have the technology. But Vesalius gives birth to the modern anatomy and allows for more people to look into it. So, in some ways, Vesalius is to anatomy as Copernicus was to astronomy. And William Harvey is kind of like the Newton, if you will, of anatomy. He's the one that discovered the circulatory system. Very sad over here. We see this is kind of an experiment. This is William Harvey. He has students around him. And what we see is he is about to cut into this dog to prove that the heart was beating and the center of the circulatory system. For you guys who love dogs like me, it's sad. Most likely the dog wasn't sick, but that's another story. He published his work in 1628 on the movement of the heart and blood, and he is the one that identified the heart and arteries as the key components of the circulatory system. Though through his dissections, he discovered the heart was the center of the circulatory system, and he was able to prove it. So in some ways, Harvey is kind of the Newton, as I've already said, to Vesalius. By this time, the modern view of anatomy was becoming more and more accepted, and Galen is being rejected. Now, let's go to chemistry. This is a famous painting I've had the privilege of seeing in the National Gallery in London. If you ever get a chance, I do love this. I love this painting. This is oil. Of course, it's oil. Look how realistic. And look at how radiant the light is. It's a beautiful piece, but I digress. This is Robert Boyle. And he's doing a special experiment here about gases. And you see this bird up here. The bird is in the little test tube. You see the girl can't watch it because I'll let you draw a conclusion of what's going to happen to the bird. But with that said, he created the first controlled experiments. From what I understand, he realized there needed to be variables and constants and all that good stuff. You should already know that he studied gases. You should know that he's the one that identified the atoms. Through his study of chemistry, he realized there was something most likely smaller in matter. He theorized about atoms, and that will be proven later. He developed the Boyle's law, which is about gas. Make sure you look that up. But ultimately, everything Robert Boyle does is create this element, and this painting helps kind of glorify his works. Robert Boyle really gives the first steps toward chemistry. I would probably say he was the father of chemistry, but I'm not a scientific historian because most historians believe Lavoisier is the father of chemistry. That's the reason I do point out the little question mark. I'll let you decide this. This is a wonderful piece of art by David. We'll talk a little bit about that later, maybe. This is his wife. This is Lavoisier, and this is his experiments. Now, it's kind of weird that that's how he dressed for his experiments, but that's cool. Oops, I didn't want to do that. All right. So you already know that he invented a naming system of chemical elements, and that's why Dr. Spivogel did ponder if he was the father of chemistry. I think the most important thing he does is something Dr. Spivogel does not provide. It's the natural law of conservation of matter. According to the natural conservation, he proved this through his study, and the natural law of conservation of matter says you can neither create nor destroy matter. For the most part, he gets rid of the whole idea of alchemy. A little bit later, we'll finalize, prove it, get rid of that in the mid-1800s. But this is the first step towards putting the stake in the idea of alchemy. If you can neither create nor destroy matter, matter exists, then there is no such thing as magic. But again, that helps bring us to an end. We see this idea about the chemistry, the scientific revolution, and let's go ahead and draw a nice conclusion. We'll know more about this. This is called Salons in Paris. This is where all the cool intellectuals met during the 18th century, and we'll see this more later. But by the end of the 18th century, the scientific revolution had disproven many of the previously held scientific truths. What was once true is no longer true. Galen, Aristotle, Ptolemy, those guys suck. They're not right at all, and we're about to move on. They had radically changed the way the Westerners viewed science. It's much more mechanical, where machines, we're going to see how weird this gets. And they discovered the mysteries of nature. They're no longer mysterious. They're rational. They're logical. And this changes the way people see the world. And through that, many more scientists began to say, if there's no mysteries in nature, maybe there's really no mysteries in society. And they want to bring this rational, logical approach to politics, religions, and society. They're going to ask the question, what is truth? That's going to be more about next week, and I hope you've enjoyed this lecture. You guys have a great day.